All right, so starting off with our arithmetic sequences, I got 3 examples there. I got 1, 3, 5, 7, 4, 7, 10, 13, 8, 3, negative 2, negative 7. Those are 3 examples of an arithmetic sequence. Arithmetic is a sequence where the difference between the 2 consecutive terms is always the same. So like my first example here, you're always adding a 2 to get you to one term to the next. So you're constantly adding the same value. My third example, we're always adding a 3. This one was plus 2. Third example, we're always subtracting a 5 from there. So it's always the same number that's being added or subtracted. We call that the letter D. We call it a common difference. What you're going up and down by, that's your letter D. Some patterns you're going to be able to see easily, and you're going to be able to pick up quickly what it is that we're adding or subtracting. If you cannot, the way we figure it out is you can pick any term, just not your first term, but you can pick any other term and then subtract the previous term from it. That is what's going to be your common difference. So if you can't see easily, pick a term, subtract the one from before it. So let's first look at these examples. We're going to figure out, is it arithmetic? If it is, then we're going to figure out what the common difference is. So 2, 4, 8, 16. Are we adding the same number each time to move through there? No. So that one is not an arithmetic sequence. My second example there, negative 6, negative 12, negative 18, negative 14. Am I adding the same number each time or subtracting? Yes. Our common difference this time is a negative 6. Keep subtracting that 6 over. And then my third example there might be a little trickier to see. So again, what we can do, I can take my second term, which was that negative 2 plus 4i, and I can subtract the first term from it, the negative 3 plus 2i. What do we end up getting when we subtract those? 1 plus 2i. Now, if it's an arithmetic sequence, I can do that with my third and my second term. I can subtract them, and I should get the same exact number. So if I take my third term, subtract my second term from that, what do we get? 1 plus 2i. So yes, this is arithmetic. Our common difference this time is 1 plus 2i. So if you aren't sure, check it. Make sure it's always the same number every time. So if we have the example 5, 8, 11, 14, how could we go about finding the 20th term? One way is you could add till you get to the 20th. You could just sit there and just keep adding your common difference, which in this case would be a 3. Keep adding 3 until you get to your 20th term. That's one way you could do it. Although if they had asked me for my 50th term, I would not want to sit there and keep adding until I got to my 50th term. What was another way that we could do it that we were going about last time with? Yeah, we could write an explicit formula. And then use that formula to find your 20th term. That was the other way that we've gone about it. So we have a formula that was given to you on your reference sheet that helps you write that explicit rule much faster. A sub n equals a sub 1 plus d times n minus 1. So again, you don't have to memorize this formula because it is one given to you, but you do need to know how to use it. So, little vocab review. What does that a sub n mean? The term, that term in the future that we're trying to figure out. We call that our nth term. So that's somewhere in the future we're trying to figure out that one. A sub 1 is our first term. D, that's our new one. We just learned that one. It's our common difference. And then N, remember that was your position. Which term is it that you are looking for? No, not previous. No. If it was A sub n minus 1, that's previous, but just n minus 1, that's not previous. So n is our position. Why do you think we would subtract a 1 from it? Like, let's say I have my sequence here. Yeah. So essentially, what you're trying to think about is how many times you have to add that common difference to get you to the term you want. So if I want to get from my first term to my fourth term, how many times am I adding my common difference there? 3. So it's always 1 less than whichever term it is that you're looking for. Some people like to refer to it as how many jumps you have to make to get you to the term that you want to be at. So up here in this example, if I wanted to get to the 20th term, I'd have to make 19 jumps from my first term to get me there. So my formula that I could use here for my 20th term would be my first plus the common difference times 19, because I would add it 19 times to get me there. And that's where this formula came about from. So let's look at our second example here. They want us to find the 68th term in the sequence, 16, 7, negative 2. Definitely don't want to be adding that to get to my 68th term. So things that we know our first term is 16. What is our common difference? Minus 9. You subtract 9 each time to get you from one term to the next term. And we're trying to figure out our 68th term, so our n is going to be a 68. So all I'm going to do is plug into that formula that we just went over. So instead of a sub n, I'm going to have a sub 68 because I'm trying to find my 68th term. So it's my first term. I'm going to make it minus because my common difference is a negative 9. So instead of plus negative 9, just minus 9. And then it's going to be a 67 because subtract 1. Got to make 67 jumps. Go ahead and plug that in and see what we get. What's our 68th term? Should be kind of a big negative. Negative 5 and 87. All right, try again. Given an arithmetic sequence, first term of 2, common difference of 3, find the 16th term. All right, so again, what we know, we were told our first term is 2. We're told our common difference is what? 3. We're trying to figure out which term. 16, so n is a 16. So again, we'll just plug it into our formula up there. A sub 16 equals 2 plus 3 times 15. Our 16th term is 47. All right. So I don't have to keep flipping. Let's rewrite our formula up there. Write a formula in explicit form that could be used to find any term in the sequence 2, 5, 8, 11. So because we are writing a rule in explicit form, we only need to know 2 things. We need to know our first term and our common difference. So of our sequence over there, what's our first term? Common difference is, so n is going to stay as n in our formula. Because again, we're just writing a general formula that we could be used to find any term. So it ended up being 2 plus 3 times n minus 1. Distribute your 3, combine your like terms. What do we end up getting? I got a 3n what? Minus 1. And as we talked about last time, what kind of a formula does that look like? It looks like a linear. That's mimicking our mx plus b, because your arithmetic sequences will always mimic a linear function. So they have a lot of the same properties. So our recursive formula, how many pieces do we have for a recursive formula? Always got to have 2 pieces. First part is you always have to tell me what your first term is. So a sub 1 is a 2 here. And then how are we getting from one term to the next? Adding 3. So we have to take our previous and then plus 3. So that would be our recursive formula for this sequence here. All right, so our next one, which term of the arithmetic sequence 15, 13, 11 will negative 13 be? So, we know our first term, starting off at 15. What's our common difference? Negative 2, because we're going down by 2. Do I know my n this time? No. What we know this time is our nth term. We know a sub n is a negative 13, so we know some term in the future. We're just trying to figure out how far in the future is that term going to be. So it's going to end up being negative 13 equals 15 minus 2 times n minus 1. Go ahead on your own, solve for n, see what you get. So negative 13 is our 15th term for that sequence. So you can graph sequences if you wanted to. As I keep saying, those arithmetic sequences mimic linears. So if you were to graph them, it would be a linear graph as well. Common difference is the slope of our formula there, or of our line there. So if we take a look at our formula that we just went over there, our a sub n equals a sub 1 plus b times n minus 1. Do you guys remember this formula? I believe you did it last year in geometry. You guys remember what this one's called? Point slope. So you got the slope, y1, x1, that represents a point. So if I add my y1 over, again, it's the same exact formula. They're just doing different letters. So it's all linear. It's all the same stuff. Just the letters that they're using are changing a little bit. So let's take a look at our sequence that we have here, 3, 5, 7, 9. Again, you always have that option of making it into a table of values if that's the way that you see things a little bit clearer. So we have 2 options. We can try to write our equation following mx plus b, but instead of x you would have an n. Or you can use the new formula that we've been going over. So this is kind of like what we were doing last time over here, where you'd figure out your slope. So in this case, what are these always going up by? Plus 2, so this would be a 2n. To get our b value, how did we do that? Yeah, we worked backwards. So our b value here would be a positive 1. So you can go about getting your equation that way. That still works. Or some people just find this formula over here to be a little quicker, because then they don't have to do the whole working backwards to find your b value. Distribute your 2, combine your like terms, and again, you still end up with the same equation. So you got a couple of options for these. But one of the main things to remember, common difference is just like your slope. So if we look at example 6 here, each day Susie waters her plants from a water in her rain barrel. On day 1, the barrel held 45 gallons of water, and on day 6, it had 30 gallons of water. Write an explicit rule to find the amount of water in the barrel on the nth day. So our information here, just like we did back in Algebra 1, it creates 2 points that you could graph. Day 1 has 45 gallons of water, so that creates the point 1, 45. Day 6 has 30 gallons, so 6, 30. So we have 2 points of information. Our common difference, because it's just like slope, you can find it just like you would your slope by calculating y minus y over x minus x. So 30 minus 45 over 6 minus 1. So that gives us negative 15 over 5. So we have a common difference of negative 3. So again, write an explicit rule. So I'll use our other formula. Day 1, we had 45 gallons, so my first term is 45. Minus 3 times n minus 1. So again, distributing your negative 3, combining your like terms. There's our explicit formula, negative 3n plus 48. So even though they call it a sequence, you can still use all the same properties of our linears because an arithmetic mimics the linear. And we'll pause. So with our arithmetic sequences, because they are always constant and always increasing or decreasing by that same amount each and every time, it doesn't matter which section of the sequence you're looking at, you can always treat it to be exactly the same. So for example, number 7, find the 20th term of an arithmetic sequence where the 4th term is a 12 and the 7th term is a 24. Again, first thing we got to figure out is that common difference. And so we can just use our slope formula. 24 minus 12 over 7 minus 4. That's going to give us our common difference here. So we end up having a common difference of 4. They want us to figure out the 20th term. So in our formula that we were using, our a sub n, equals a sub 1 plus b times n minus 1. You have to know your first term for that one, but you don't always need to use your first term, though, to figure it out. I know my 4th term and I know my 7th term. I'm going to use my 7th term, just because that one is the closest one to my 20th term. How many jumps are going to happen from my 7th term to my 20th term? 13. You would just do your 20 minus your 17. There's going to be 13 jumps. Just like if it was a first term, 20 minus your first term was 19 jumps. No matter which term you're using, you subtract it from the one that you want. That's how many jumps are going to happen. So my 20th term would be my 7th term plus my common difference times my 14 jumps. So wherever you are, just figure out how many times you got to add and then go with it. So what do we get? 4 times 13, 52 plus 24. Our 20th term is a 76. So number 8, we have a 5th, a 6th, and a 7th term of a sequence are 20, 21 and a half, and then 23. What is the first term? So again, first thing I need to know, what is my common difference? It's going to be 1.5. That one's a little easier to see the common difference right away. So then to get my first term, I get to pick. Do we want to use our fifth, our sixth, or our seventh term? All right, we'll use our fifth term. So 20 equals, I'm just plugging into my formula up above. I don't know my a sub 1. That's what we're trying to find. We just found our common difference to be 5.1. And then it's going to be times 4 because it was n minus 1. N was a 5 since I used my fifth term. So 5 minus 1 gives me 4. So let's see here. 1.5 times 4 is a 6. Subtract my 6 over. Our first term was 14. So 9, we got to find our 8th term. Given that our 5th term is a 41, our 11th term is a 17. So again, using our slope formula, let's figure out our common difference. So 17 minus the 41 over 11 minus 5. What does that give us? -4. So our common difference is -4. I'm going to use my 5th term this time because my 11th has already gone beyond my 8th term. I'm trying to find my 8th term there. So my 8th term will be my 5th term because my common difference was negative. It's going to be minus my common difference. And how many jumps from my 5th to my 8th term? 3. So 41 minus 4 times 3. My 8th term is 29 there. So again, with arithmetic, get the common difference if you don't already have it, and then you can figure out what your other terms are from there. Sometimes our patterns do involve some algebraic expressions in there. So in our next example, we have x plus 3, 2x plus 5, 3x plus 7. What is our common difference? Again, some people can probably just look at it and they can already figure out what it is. If you can't, any term, yeah, minus the one before it. So I can do my second term minus my first term. We would end up getting x plus 2. So in our second part, what is the explicit rule to find the nth term? So our a sub n, again, I'm using that formula that we've been working with. Our first term is x plus 3. I only put it in parentheses because I've gotten into a habit that once it's a binomial, I start putting parentheses in there. Plus, our common difference, though, absolutely has to be in parentheses because remember, that's got to get multiplied by that n minus 1 at the end. So our first term plus our common difference times n minus 1. So now let's go ahead and plug in 7 to figure out what our 7th term is. Seven x plus 15, hopefully is what you got. All right, one other thing with our arithmetic means. Arithmetic means are the terms between any two non-consecutive terms. So right here, this example right here in number 10, they have 3 arithmetic means between 86 and 110. So that just means there's 3 terms in between them. So in order to find the missing terms, again, gotta find that common difference. Arithmetic is always about that common difference. I know my first term and I know my 5th term. If I count them out, I got my first term, I got my fifth term. So we can use our slope formula. (110 minus 86 over 5 minus 1). What does our common difference end up being? 6. So all we have to do is just add 6 to find our missing term. So 86 plus 6 plus 6 plus 6. And then if I add 6 again, do I get 110? Yeah, so we're good. Form an arithmetic sequence that has 5 arithmetic means between -11 and 19. So that, again, simply means that there are 5 terms in between the -11 and the 19. So we got 5 missing numbers there in between those two. So that means the -11 and the 19 are the first terms, and it's the 7th term. So now we can figure out our common difference using our slope formula. So what does our common difference end up being? 5. And then we just fill in our spaces by adding 5. So -11 plus 5 plus 5 plus 5 plus 5 and plus 5. There we go. We formed our sequence. And then our last one on here, find the arithmetic mean given that a sub n minus 1 is 12 and then a sub n plus 1 is 18. Let's think about what these mean again. N minus 1 is what? Previous. N plus 1 is what? Next. So if I am sitting in a space, my previous term is 12. My next term is 18. So pretty much there's just one number in between those two. So we have our previous, we have our next. We're looking for what we refer to as the current one. So again, this is term 1 and 3 that we know, so we can get our common difference using that slope. So what is our common difference there? 3. So our arithmetic mean is 15. Geometric sequences are next. Geometric sequence is the other kind of sequence that you did talk about back in Algebra 1. We had the arithmetic and the geometric. Geometric has what we call a ratio, because the difference between geometric and arithmetic is geometric is multiplying consistently by the same value, where arithmetic was adding consistently by the same value. So since it's multiplying this time, we have a common ratio, which gets represented by that letter R. And if you ever need to figure it out, your common ratio is any term other than the first one divided by the previous term. So your second term over your first term, or your third term over the second term. So any term divided by the one before it. So let's see if we can figure out which ones are geometric and which ones are not. So again, geometric has to be multiplied by the same number every single time. So A, is that being multiplied by everything? Nope, because this would be times -2, but times -2, is that 45? No, so that one is not geometric. How about letter B? Yes. What are we multiplying by? -2/3. And then letter C? Yeah, what are we multiplying by? 2x. So geometric, repeatedly multiplying. Since it's repeatedly multiplying, what kind of function would that mimic? Exponential. Exponential is our repeated multiplying one. So example 2, show that the sequence defined by a sub n is 2 to the negative n is in fact geometric. So what we're going to want to do is figure out the first few terms of this sequence. So we'll figure out the first term, which would be 2 to the negative 1 based on my formula there, which equals what? 1 here. My second term would be 2 to the negative 2, which would be what? 1/4. And then our third term, 2 to the negative 3, which is 1/8. So again, we were told to show that it's a geometric sequence. So the way we do that is by showing that it has that common ratio. So I'm going to take my second term of 1/4. I'm going to divide it by the first term of 1/2. What do we get when we divide that? 1/2. Fractions, remember, keep, change, flip, so it's really 1/4 times 2. Or you can use your calculator to help you with that. See if it's the same ratio if I do my third term divided by my second term. So 1/8 divided by 1/4 gives us 1/2. So yes, it is geometric because the ratio stays the same. That's consistent. So example 3, the first three terms of our sequence are 8b, 16b squared, 32b to the third. What is our sixth term? Well, let's figure out first, what are we multiplying by? 2b. So let's just keep on multiplying by it. So 32b to the third times 2b. 64b to the fourth times 2b. And times 2b. There's our sixth term, 256 times b to the sixth. So in number 4, we have x plus 6, 2x plus 3 are consecutive terms of a geometric sequence. They want us to find the value of x. So again, with a geometric sequence, your ratios have to be the same. So if I take my second term and divide it by my first term, that has to be equal to my third term divided by my second term, because the ratio is consistent. So what do we do to solve this? Cross multiply. Go ahead and cross multiply. So you hopefully got 12 and negative 3 after you factored and set everything equal to 0. So then you got to check to make sure that they work. So when x is a 12, because that was my first value that I had, I'm just going to plug it in over here for what they said my first three terms were. My first term was x, so that means 12. And then I had x plus 6, so that's going to be 18. And then 2x plus 3, let's say 27. So then 18 over 12, what does that reduce to? 3/2. 27 over 18, 3/2. So it works. So x being 12, that's a viable answer. We get to keep that one. Let's see if it works also for when x is a negative 3. That means my first term is negative 3. But I plug it into that second one, negative 3 plus 6 gives me 3. Plug it into that third one, 2 times negative 3 plus 3, negative 3. This one's a little easier. What is our ratio that we're multiplying by? Negative 1, so yeah, that works also. They don't always, so you got to make sure you check to see if they work. In this case, both of them did work. So x could be 12 or x could be negative 3. So let's consider the pattern 2, 4, 8, 16. How could you figure out the 9th term without just keep multiplying by 2? Yep. Very close. So our ratio here would be what? 2. We're multiplying by 2. How many, it's kind of like our arithmetic. How many times would I have to multiply by 2 to get from my first term to my 9th? 8. We'd have to do 8 jumps. So that means this ratio is being multiplied 8 times. I can show that by using a little exponent of 8. That 2 is being multiplied by 8. But again, we always have to start with that first one. So I started at a first term of 2, and I multiplied it by my ratio of 2 8 times. So what does that give us for a 9th term? I got 512. Okay. So let's change our pattern a little bit. So let's say we have 2, 6, 18, and 54. What's our ratio this time? 3. So our first term of 2 gets multiplied by our ratio of 3 how many times to get to our 9th term? 8. So what do we end up getting here? Should be a really big number. Not quite that large. You got 13,122. So that's how we figured out for our geometric. So that's where this formula down here came from. A sub n, so some term in the future, is your first term times your common ratio to the n minus 1 power. So again, a sub n, that's our nth term. A sub 1 is our first term, and then the r is your common ratio. And then that n minus 1 just helps us figure out how many jumps happen. So you figure out, take your term, subtract the first from it. So example 7, given the sequence 8, 4, 2, 1, write a general formula for a sub n, and then determine the 8th term for it. So I'm going to be following my formula right up there. So a sub n equals, what's our first term? 8. What's our common ratio for this one? 1/2. And then it's going to be to the n minus 1 power. So there's the first part. Write the general formula. There's the general formula for you. Using this formula, figure out that 8th term. All right, example number 8. We got a first term of 4, an r of 0.1. Write the first 3 terms of the sequence and then find the 10th term. Well, first term's already given to us, so that one's pretty easy. Second term, so just multiply 4 times 0.1. What do we get? 0.4. Multiply again times 0.1. 0.04. So there is our first 3 terms. 4, 0.4, 0.04. Figure out our 10th term. Let's use our formula. First term is 4. R is a 0.1. And it'll be to the 10 minus 1 power, so the 9th power. What do we end up getting? Or did it actually put it that way? Most calculators probably have the E -9. Yeah, so that's our scientific notation. So that's 8 zeros. And then your 4. So 9, find the first term in a sequence whose common ratio is 2, and the 6th term is 96. So again, using our geometric formula we've been given, we can use this to figure it out. We know our nth term this time. That's our term somewhere in the future. That's our 6th term. So I'm going to put 96 in for my a sub n. We're trying to figure out our first one. Our common ratio is a 2. And then 2 would be to the 5th power because it would be 6 minus 1. So that's going to be a 5. So 2 to the 5th is what? 32. So what would we do with our 32? Should divide. So our first term is what? 3. All right, number 10, what is the common ratio in the geometric sequence T sub n equals 5 times 3 to the n minus 1? That's not a trick question. Just look at your formula. Your common ratio is 3. Whatever has your exponents on it. So now figure out your third term. So plugging a 3 in for your n. So it ends up being 5 times 3 squared. So what does our third term equal? 45. In a geometric sequence, we have a 6th term is 48. 7th term is 24. What is the first term? First thing we should figure out is our common ratio. Because I know my 6th and the 7th, I would have to do my 7th term divided by the 6th term, because it's always a term divided by the one before it. So that's why it's got to be 7 divided by 6. 1/2. So then again, we get to pick. We can use either the 6th one or the 7th one here. It doesn't matter. I'll go with my 6th term. So my a sub n is 48. Trying to find a sub 1. And then my common ratio is 1/2. So it's 1/2 to the 5th power. So 1/2 to the 5th is 1 over 32. How do we get rid of the 1 over 32? Multiply by 32. So your first term is 1536. So again, it's all about plugging into that formula when you can, and then just manipulating to find the value they're looking for. Initially, a pendulum swings through an arc of 18 inches. On each successive swing, the length of the arc is 0.98 of the previous length. 0.98 is telling us that it's a percentage, so it's 98% the length of the other one, so that's how we know it's geometric. So they want to know what is the length of the arc on the second swing. So first swing was 18 inches. Multiply it by the 0.98. How long was the second swing? 17.64. So next they want to know, what is the length of the arc on the 10th swing? So we'll use our formula that we've been using. A sub 10 be the first swing, so 18 times 0.98 to the 9th power. What do we get? We have 15 point what? 0075, right? Yeah. You guys are going to love this one. On which swing is the length of the arc first less than 12 inches? So what would I plug 12 in for? Yeah, our nth term. So 12 is going to go in for our nth term. So that's going to equal 18 times 0.98 to the n minus 1 power. So we're trying to figure out what position, so which swing is it when it gets to that 12. So what should we do first? Divide by 18. Because you want to get the thing with the exponent by itself. So in this case, it's the 0.98. Over 18 reduced to 2/3. Now what do we use to get something out of an exponent? Logs. They don't go away. So we have to take the log of both sides. So log of 2/3 equals n minus 1 times the log of 0.98. So then what would we divide by to try to get n on its own? Yes, so we would have the log of 2/3 divided by the log of 0.98. And then our last thing we would have to do with the 1, add it. You're going to get a decimal, so go ahead, type that in. Let's see what we get for a decimal. .07. So on which swing would it actually be less than 12? On the 22nd swing. Because on the 21st swing, it's still going to be more than 12. You got to go a little beyond that 21st swing. So that means you got to go on the 22nd swing, and that's when it'll finally be less than 12. All right, geometric means, just like arithmetic means, those are your terms in between. Just we have to figure them out a little bit differently because it is geometric instead of our arithmetic. So looking at our first one, my missing term here, I'm going to call that x. So again, geometric is all about the ratios. So the second term over the first term has to be equal to the third term over the second. That's how we figure out our common ratios. So we set them equal to each other, and then we can cross multiply. get x squared equals 1600. Square root both sides, and what do we get? Plus or minus 40. Plus or minus 40. Because my ratio could be a positive 2, in which case 40 is going to be my middle number there. Or my ratio could be a negative 2, in which case negative 40 fits. There's not enough information for us to determine which one it's going to be, so it could be either one. So it could be positive 40 or it could be negative 40. Now this one, our next one, this one gives us more information. Because I now know that my fourth term is also positive, that means my second term is going to be positive. So we're not going to be able to have a negative option for this one because we had that more information of that fourth term to be able to tell us. So same way, that term that I'm missing, I'm going to call that x. Second term over the first term has to equal the third term over the second, so that the ratio is equal to each other. So we can cross multiply, so x squared equals 3 times 48, 144. So square root both sides. You get x equals 12. And again, we know it's only positive 12 because all of the terms in our sequence are positive. So x has to be a 12 there. Now letter C, a little bit different. We're missing 2 terms. We know a number. We're missing 2 more terms. We know a number. The number 3 is technically my third term right now, but I'm going to kind of pretend right now like that's my first term. So that would make 1/9 my fourth term. So I'm going to kind of call that my nth term for now. So my nth term, which I'm using as 1/9 as my fourth, equals my first term, which I've said is now that number 3 right there, times my ratio to the third, because it was 4 minus 1 in my exponent there. So now we can figure out what our common ratio is. So divide by 3. 1/9 divided by 3 gives us 1/27 equals our ratio to the third power. Couple of ways we could go about figuring this out now. Well, that's one way. You could cube root each side, or reciprocal power also, which really it's the same thing. What's the cube root of 27? 1/3. So we have a common ratio of 1/3. So then going from left to right, 3 times 1/3 would be 1. 1 times 1/3 would be 1/3. But now I have to figure out my other 2 blanks. So I'm going from right to left. I'm going backwards. So what would we actually be multiplying by? 3. Good. So 3 times 3 is 9. 9 times 3, 27. So there's our sequence. And then just the last thing, geometric sequences mimic your exponential functions. So their graphs also look like exponentials. Your common ratio is your base. So again, sequences can be written into tables. So I could make that 3, 6, 12, 24 right there. If we were to graph it, your term, which is known as your a sub n, would be your y-axis. The position, or your n value, would be your x-axis. So then you would go and you would plot your points. We're just going to estimate for now. Would we want to connect them? It's a sequence, so does it include the values in between 3 and 6? No. So we wouldn't want to connect them. It would just be points. But the points follow that little curve shape of our exponential. Same thing happens with the other one, which just ends up being a decay one. This one's a decreasing one. So your term, still your y-axis, your position is still your x-axis. And again, just estimating where our points would be. Because it's a sequence, we don't want to connect those. So just practice one more time. We're going to do explicit for both of our graphs, and then we're going to do a recursive for both of our graphs. So our explicit rule for the first one, what was our first term? 3. What was our common ratio? 2. Multiplying by 2 to get from one term to the next. There's our explicit rule. Our recursive rule, remember recursive always has 2 parts to it. You always have to state your first term. And then we're multiplying 2 by the previous term. So 2 times a sub n minus 1 would be our recursive rule for that one. Our last graph, our explicit rule, first term is 27. Our common ratio is 1/3. 27 times 1/3 to the n minus 1. Our explicit rule, first term, so a sub 1 is 27. And then 1/3 times your a sub n minus 1.